So we do have a couple of questions that we're going to get to before we take a short break. The first question is for Tony, and this is from Gerardo Dominguez, who asks what isotopes would be targeted by the Viper mission.
Specifically, oxygen and hydrogen, deuterium, hydrogen, oxygen isotopes are the ones we're most interested in. We have a mass range up to 100, and M-Solo can operate in a high-resolution mode. So it really comes down to what the concentrations are and whether or not you have enough dynamic range signal of noise to detect the particular isotope of interest. But they've demonstrated the range of sensitivities for oxygen and pH right now.
All right, thanks, Tony. The next question is for the landed mission folks from Julie Mitchell, so maybe Tony, James, or Deborah could chip in. But the question is, to what extent do you expect heat to be transferred from the hardware to the PSRs that are being sampled?
That's a great question, and one we've been looking at a lot. So the good news is, to survive a cold night, up to 96 hours was the design requirement. You need to really tuck yourself in with a whole lot of multi-layer insulation. And that's good in the sense that we are really thermally isolated, except for the radiator on top of the rover, to the environment around us. So we are emitting very little energy out to the surface, which is great. We have lights, of course, going into the PSR, LED lights, so we can navigate. And we've looked at the total temperature change, working with Matt Siegler and others, that light would actually impart. And it does. It will warm the surface up in the top microns or so over several minutes of operation. So we have to take that into account. One way we do that is we don't operate the lights continuously. We don't want to from a power standpoint anyways, so we just flash them. So we understand we're going to impact the environment somewhat. We think it's rather minor and should be at just the surface. While roving, NERVIS measures the surface temperature, so we'll be able to understand exactly how much we are changing the environment as we rove along. It's a great question, though.
Yeah, I agree. Thanks, Tony. And James, Deborah, did either of you have anything to add on to that response about heat transfer?
So certainly on the prospect side, it's one of the investigations we're looking into a lot at the moment, is how the lander and the drilling itself will impart heat into the subsurface, and how that would affect the measurement. So we've identified it as an issue. We're trying to look at ways of operating the drill such as we could minimize the heat transfer by looking at the permittivity. Is one way that we can perhaps look at bulk phase changes are being introduced during the drilling, we've got investigations actively being undertaken now to look at the effects we might have and how we can mitigate them.
Yes, and similar response for the CLIPS delivery. A part of it is also organizing the measurements that we want to make and making sure that we can make the CONOPS, the concept of operations, to make sure that the measurements that we need to make are made before the lander starts affecting the substrate too much. But it's certainly going to influence and have an effect on the local substrate. So that's definitely something that we're looking into, and will depend on the specific site that's selected.
All right, thank you all.